Chapter 10.7, we're looking at polar coordinates. We're going to plot points in the polar coordinate system. We're going to convert points from rectangular to polar form and vice versa. And then we're going to convert equations from rectangular to polar form and from polar form to rectangular form. As an introduction, we have been representing graphs of equations as collections of points x, y in the rectangular coordinate system, where x and y represent the directed distances from the coordinate axes to the point x, y. So for example, we have our coordinate plane here, and then we go right, or left, the x value, and up or down the y value. And so now we're going to look at a different system called the polar coordinate system. To form the polar coordinate system in the plane, we're going to fix a point O called the pole or origin and construct from O an initial ray called the polar axis, as shown in the figure on this on the right. Then each point P in the plane can be assigned polar coordinates r theta. And so r is the directed distance from O to P, and theta is the directed angle counterclockwise from the polar axis to segment OP. Okay, so just notice this is r and theta. Theta is our angle, and here is the directed distance. So let's get a little bit of practice, just an introduction to plotting points in the polar coordinate system. So if we have 2 pi over 3, so 2, we look at these rings here, and so this is 1 and this is 2. Then we go to pi over 3, so it is this point right here. So 2 pi over 3, and then so this is our point here that we were trying to get out. And so we can label that point as 2 comma pi over 3, and then we can say this angle, theta, is pi over 3. So let's try the other one. 3 negative pi over 6. So 3 rings out, 1, 2, 3, and negative pi over 6 is right here. And then we draw this here. And now we have 3 comma negative pi over 6 as this point, and we know that our angle theta is negative pi over 6. Number 3, that is, or letter C, that's 3 11 pi over 6, so we know there's 3 rings out, and then we rotate all the way around, and we see that it is right here. Notice it's the same exact point. So 3 comma 11 pi over 6, and we know that that angle, theta, is 11 pi over 6. So try these out. Plot each point given the polar coordinates. So if we tried this out, you would have gotten these points here. Notice B and C again are the same exact point, which goes into our next section. So in rectangular coordinates, each point x, y has a unique representation. Now this is not true for polar coordinates. For example, the coordinates r theta and r comma theta plus 2 pi represent the same point, as illustrated in these here, right? In our B and C here, they're the same exact point. Another way to obtain multiple representations of a point is to use negative values of r. Because r is a directed distance, the coordinates r theta and negative r theta plus pi, these ones here, r theta, and negative r theta plus pi represent the same point. In general, the point r theta can be represented in these two ways. So r theta can either be r and then theta plus or minus 2 pi, and that should make sense, just 1 or 2 rotations around the circle. Or the other way is you change this to a negative r, and then you take theta, and now this is 2n plus 1 pi. So what is 2n plus 1? Well, that's going to be odd, right? So if you try it out, just plug in any number. So 2 and, let's say 2 times 0 plus 1, so that's going to be 1. If we do 1, 2 times 1 is 2 plus 1, which is 3. And so you're adding odd values of pi. So 1 pi, 3 pi, 5 pi, so forth, and then plus or minus those values. And the pole is represented by 0 theta, and theta is any angle. So let's look at this example. Plot the point 3, negative 3 pi over 4, and find 3 additional polar representations of this point. And we're using between negative 2 pi, theta, and 2 pi. So if we take 3, negative 3 pi over 4, what we could do with this is, let's go ahead and, since it's negative, let's add a 2 pi to it. So if we're adding 2 pi, we're really looking at converting it to 8 pi over 4. That's the same thing as 2 pi. And now this is going to be 5 pi over 4. So it's good to, just being able to convert these if we need to, and then we'll notice some things as we start to find multiple representations of the point. So we can also always graph the 3, negative 3 pi over 4. So 1, 2, 3, negative 3 pi over 4 is going to be right here. So we label that point as 3, comma, negative 3 pi over 4. We could draw this here. Now let's find some other points. So we know this is one of the representations of the point. Now we need 2 more. So what we can also do is that it says right here that I can take the negative. So negative r, so negative 3, and then keeping the same theta, negative 3 pi over 4. And then we're going to add pi. Let's add pi first. And so this becomes negative 3, and this is 4 pi over 4. So negative 3 comma pi over 4. And then the next one, let's do another one, negative 3, so opposite, negative 3, and negative 3 pi over 4. And this time let's subtract pi. And as we're subtracting pi, that is negative 4 pi over 4. So we're looking at negative 3, negative 7 pi over 4. So what I want you to notice after we found these points here is that, notice we have negative 3 pi over 4, and where is that in this polar graph? So negative 3, we can think of it this way, and then pi over 4 is here. And then negative 3, negative 7 pi over 4, so that's negative, and so notice it kind of rotates in this direction here. So just, some kind of important points to kind of notice about this is that it was great to find the multiple representations of the points, but it's also good to kind of identify how do you graph something like this. If we're given something like this, what do you do with it? So you could always, convert it and then find the points. That way you can really see it in this plane too. Now, just as a practice, please plot this point as well, and find 3 additional polar representations of this point. So, because it's negative 1, 3 pi over 4, you may want to try to convert it first to find, the positive r and to help you out. So graphing this, you should have found that it would have been 1, 7 pi over 4 would be all the positives here, so you know kind of where it lands. And then that would have helped you out then in graphing the negative 1, 3 pi over 4. There are the other options that you could get as the representations of that single point. And again, it says between negative 2 pi, like theta is between negative 2 pi and 2 pi. And so, for example, you don't want to pick, something that's going to be outside of that range there.